Hey everyone, welcome to Talks Tutoring again. So this is a continuation from the last video for integration by linear substitution. So if you haven't checked that video already, make sure you do. I'll leave a link below, also the pop-up above. So just make sure you check out the video before you come over here, or else you'll be very confused watching this video. But anyway, let's get into this question. This is chapter 7C, question 3. I've just taken some some good-looking questions out of the textbook, and we're gonna have a go at it today. Okay, so first one, we are going to antiderive. That's pretty much the question. So I'm just gonna rewrite this antiderivative of that, and then 3x minus 1 to the power of half. Of course, antiderive in terms of x. How would you do that? Well, we've learned linear substitution, right? So you let u equals to the one that looks complicated, and the one that looks most complicated here is 3x minus 1. So we derive that and we get du dx equals to 3. The problem is now you can't eliminate. So if I was to make dx a subject, that would be du over 3. I can't eliminate 3 and 2x plus 1. 2x plus 1 is not going to disappear from 3, right? There's no x. This is not exactly 2x plus 1. So obviously we cannot use integration by simple substitution. But like I said in the previous video, you can use linear substitution if that's the case. If you want to do that, you can make now x the subject. So from this point over here, we know that if I make x a subject, it'll be u plus 1, everything divided by 3. And we're going to rewrite the whole thing again. So 2x plus 1 is u plus 1 divided by 3, and we're going to multiply that by u to the power of a half, right? Because we let u equals 3x minus 1. I'm going to replace dx with du over 3. And what we end up with is, after simplifying, is 1 over 9. The u plus 1 over here, I'm just going to put in a bracket. If you multiply that by the u over half, so expanding the bracket, you get u to the power of 3 on 2. So that's 1 plus half, plus 1 times u to the power of half, which is u to the power of half, du. And then we move on from there. If you were to antiderive this, it's just a polynomial now. So see, now the x disappeared. If you want to eliminate x, you don't have to eliminate it. You can just make x become a u instead. This only works if you get a linear substitution. So when u is equals to something linear. So that's why that's why it's called linear substitution. So polynomials, let's continue moving on. 2 over 5 plus u. This one we add power by 1. Bring it down. That's 2 over 3. Just make sure you always put a plus c. And then just expand everything. So 1 over 9 times 2 over 5. That is 2 over 45. That's a huge number. And then I'm just going to put the u back in over here. So u is 3x minus 1. So right here, to the power of 5 on 2. Plus 2 over 9 times 3, that's 27. Once again, same thing. Going to replace u with the bracket. And there we go, plus c. Okay, so that's pretty much how you solve for this first part. Integration by linear substitution. Just make x a subject instead. And then just turn x into a u. Part J. So once again, anti-deriving this, x squared over square root x minus 1. Now I know the first thing that comes to your mind is, wait, there's an x squared. This technique is called linear substitution. That's not linear, right? No, linear substitution just means you let u equals to a linear function, okay? So in this case, we let u equals to the linear function, which also turns out to be the one that looks really complicated. So you let u equals to x minus 1. Always do this, guys. The reason why we derive this is so that now we can replace the dx with a du, which is the purpose of these substitutions. Du dx is equals to 1. That's pretty convenient, so therefore dx equals du, and that's it. Just gonna keep writing it down here. Of course, from this function, x is now u plus 1. Therefore, if I was to write x squared, that is u plus 1 squared. So u plus 1 squared. And then divided by square root of x minus 1. We know that x minus 1 is u, so it's divided by square root of u. Another way of writing that is u to the power of negative a half, okay? So there we go. We can keep going on. I'm going to expand this. Oh, and dx is equals to du. So this is just du. I'm just replacing it, the dx with the du. Okay, I'm going to expand this bracket. So that's u squared plus 2u plus 1 multiplied by u to the power of negative a half. This might look really complicated, really long, but you can expand polynomials, right? U to the power of 2 multiplied by u to the power of negative half. If you multiply indices, then what you can do is just take the power minus each other, right? So 2 minus half, that is 3 on 2. So don't forget the integrand, plus 2 u to the power of 1 multiplied by u to the power of negative half, that is 1 minus half, so that's half, and then plus u to the power of negative half, okay? So once again, see, this is our polynomial. We've done this before. We can anti-derive that. Add the power by 1, so that's u to the power of 5 on 2. Bring the new power down, but divide it. Same thing over here, u to the power of 3 on 2. Bring it down, so that's 2 on 3 times 2. That's 4 on 3. And then last one is u to the power of half. I bring the half down, that is 2. And then put a plus c. Last step, all you have to do is replace the u with whatever you had. So x minus 1 half plus c. And you can leave the answer in this form, that's perfectly fine, okay? There's nothing stopping you from that. And on to the last one. This should be quite repetitive, although it does look a bit more complicated because now your function is, you know, you've got one on top of the other one. This one has a square. That's you know, it's got a lot of things going on. So once again, what do you let u equals to? This is going to be a case of linear substitution once again. I'm just going to write the integrand first. Okay, so what do you let u equals to? I'll give you guys to think about this for a second. Yeah, if you want to eliminate or you want to linear substitute, you let u equals to the one that looks complicated and it has to be a linear function. Both of them are linear in this case, so we'll just pick one, and the one that looks complicated obviously is a 2x plus 1, right? It's under the square, it looks complicated. So just get rid of it, right? And you get du dx, we derive that, we get 2. So therefore, dx equals to du over 2. Don't forget to do this step. It's very important that you get dx in terms of your du. Okay, from this step, we know that x is therefore u minus 1 and then divided by 2. So now you can linear substitute. The reason why we linear substitute is this 2 is not going to get rid of that 5x minus 1, the other function, right? So you can't use simple substitution. So I'm going to substitute it back in. X is u minus 1 over 2. What is 5x minus 1? So that's 5 times u minus 1 over 2. You can already see this becomes a little bit complicated, a little bit messy actually, over u squared. So 2x plus 1, that's u, and then we're going to replace x with dx with du over 2, which we found here. Okay, let's simplify things down first, and then we can start doing antiderivative. So 5 times u is 5u minus 5, 5u minus 5, everything is over 2, minus 1, still in the integrand, and then everything is divided by u squared, du over 2, and then I'm just going to bring the half out for now, and then you get 5u minus 5 over 2 minus 1, that is 5u minus 5 minus 2, so I'm going to bring the 2 up, everything is going to be divided by 2, and then you have the u squared du, and then we're almost done. What you can do is that half can come out as well, right? Or that half, that 2 over here can go to the denominator, but then any number you can bring out. So another way of writing this is 1 over 4, 5u minus 7. I'm going to put in a bracket and I'm going to bring the u square up as well, okay? So that's u to the power of negative 2 du. So the reason why I brought it up so that now you can expand the bracket, you can multiply, okay? And to get your polynomials. So 1 over 4, and then we're going to anti-derive 5u to multiplied by u to the power of negative 2. That gives us 5u. 1 minus 2 is negative 1. And then negative 7. There we go. Okay, so I'm just going to multiply that. And then what are you left with? Well, this is a bit of a tricky one. U to the power of negative 1. If you want to anti-derive that, remember, if I anti-derive 1 over u or 1 over x, actually that should be u, I get log e of u, right? So this is the same case. I get 5 times log e of mod u, move a little bit to the right, minus, so 7 u to the power of negative 2, that's u to, plus 1, that is u to the power of negative 1. I bring the negative 1 down, so that becomes 7 divided by negative 1, which is positive 7. And then just put a plus c, okay? Right, expand everything out. 5 over 4 log e. Okay, mod of u, I'm just going to replace u with what we did previously. So that is 2x plus 1. So I'm just going to write that. Mod 2x plus 1. And then plus 7 over 4. Okay, multiplied by u to the power of negative 1. U to the power of negative 1, I can just multiply it by 1 over 2x plus 1 plus c. And that is your final answer. Okay, so this one's a bit long, but of course, hopefully this video helps you out with this problem. But aside from that, guys, this is simple linear substitution. We've learned simple substitution. We've learned linear substitution. We've got some more techniques coming up, but so stay tuned. But aside from that, guys, thanks for watching, and I'll see you in the next video.